Okay, my friends, so we are ready to keep talking about Houdini. That's wonderful. And now what we are going to do is we're going to take this color guy that we don't need and we're going to delete it. Now we have this, we're going to take the transform. I just wanted to here to show you that we have a shear value there, so we're going to get rid of that. And now we have our color attribute, which is kind of nice. And this is the shear attribute that we created in our previous class. Now look at these values, right? And also what you can do is just take this and you can put it instead of this one, for example. Why not? You can go like that, and there we go. So now we have a beautiful color going in that direction. You can, if you want, why not? You can just take now the other one, for example, here, position set. You can copy that and you can add it to this value. Now the thing here is not because I just want you to go and copy and paste things all around. So what I want you to do is just go and try to see what happens when you actually move these values. Why that direction is moving like that. Why this is moving on the, this has to be in this side. I mean, if I am correct, yep. You can see how this is going that way. Now, if you have a minus value, you can always go like that, and that's what is going to happen, all right? So keep that in mind, please. I don't want you just to follow this tutorial, this class, and then, okay, copy, paste, copy, paste. No, please, try to understand. This is color red. This is a random function that goes and takes a value and then moves everything around. And then you have attributes inside here. This is a variable predefined inside Houdini, just like this one. And then we can divide and add operations inside that. And we need our semicolon in order to close something. And just keep those things in your head for the rest of your life. That's it. All right, so no, I'm sorry. All right, I was too excited. Now what we're going to do here is just going to create another wrangler, another super wrangler. We're going to put it in here. We're going to connect that into this one, and we're going to give it a different name. So now this one is going to be, I don't like the values of numbers at the end. I want them at the beginning, or, you know, in this case, I don't really care. So we're going to call this sharper. Okay, just sharp attribute wrangler. So that's the one. We are going to take a look at another function. So we're going to make this one visible. We still have our colors, nice colors, because we are using that. Now, if we jump into section here, there is a pow function, right? So the pow function or expression function in this case is telling us that we need to declare, you know, the value of the function, which is pow. This is the name of the function, and then we need a base value. And then we need an exponent. So the base value in this case, as the example that we have in here, so it says that pow is equals to 2, and then we multiply that 3 times. So pow by 2 is 4, by 2 is 8. So that's why we have this result. All right. Now this is using the pow expression function. But what happens if we go to pow VEX function? So kind of the similar thing. You can see that here we have a float and a vector option. So pow, we need the base or our value, and then we need the exponent, and here we can use it as a vector. So same thing, we need that and then our exponent. So don't worry about anything. Let's jump into Houdini and let's try to use it. All right, so how can we use that? Well, first of all, we could use this just like any single other type of object that we have. So for example, I can just go and I'm going to copy that and paste it, because I hate to type these values here all the time, and very repetitive. So we're going to have that, and position of x is going to be equals to position of x, and then we can say plus, right? Now let's call our pow function. So here's our pow function, and we have that ready there. And now we can just say something like in the example that we saw, 2 times 3, and then we close that with our semicolon. So that should be doing something, right? And that's what's going to happen. Now if you take a look in here in the x direction, so remember 2 times 2 is 4, 2 times 4 is 8. So now this the actual position of this object should be 8, and you can see that here minus 5, and you're probably like, Carlos, you're wrong. But no, this is minus 4, because we have from the center minus 4 to this section, that's 4, and then plus 4 here we have 8. So that is what is that's what is happening. All right, so now we can do the same thing. We can take that, copy, and then we can paste it underneath, and we can say now you're going to do the same thing for my set value, and look what happens if I do that. So if I just change that, that's what I want you to see. What is happening here? We are adding, all right? We are just adding and accumulating to that X position. So now instead of having just the 8, we are having this value, all right? Because we are connecting X and then we are adding that to X at the power, and that's what set is doing with our X position. Okay, set is doing that because set is playing around with the X position. So now if I want to, I can just change that into set, and now set is going to take control of just its area. It's going to be 8, and then X is going to be controlled by its own 8 value, right? So we have this nice 8 by 8 kind of pancake, all right, color cake, and that's really nice. So that's what is happening, and that's the thing, you know, about learning VEX is not about just copy pasting. And I mean, I just don't like tutorials where I just see a whole explanation of why and then and all these kind of things that just kind of make my head, you know, I don't know. I just remember a long time ago when I was trying to understand what's going on here. It was terrible, but the thing here is that it's just try to see it as English or as your native language. So what means this is position? Like I said, I'm going to repeat a lot of things once in a while. That means that we have a declare variable in here, okay, contained by Houdini. Okay, I don't know what I did in here, but then dot x means that we are working with the x position and so on. So our power function. Now let's go and try something a little bit more crazy here. So I'm gonna go here, I'm gonna create a new channel. Now this channel is gonna be an F channel, so floating channel, and I'm gonna open and close my parentheses. Here I am not gonna put my semicolon because this is not the end of the sentence or the expression, right? So let's call this sharp, okay, or sharper, and then in here we are going to just leave it for now and just leave it like that. So I'm just going to create my value, my parameter, and now you can see that I created my parameter, and now the power of x is going to be 0 because I mean the power of position of x right now is 0, and then multiply by whatever is going to get 0. So you need to start increasing this if you want to make something happen. All right, so this is the sharper, and now I have this value that I can use and make it grow if I want to. Okay, so that's beautiful. Now we have that thing and that thing happening. Now what I can do in here as well is just go and take, for example, from my color, I can say, you know what, I want this, but you know what, no, I'm going to show you first, just a quick thing here. I'm just going to take that channel, I'm going to copy it, and I'm going to put it in my 2 here so that you can see, you can create this kind of effect if you want to. Now the same sharper is going to be the value that is going to allow us to make this thing kind of you know, skinny, all right, or fatter as we move this thing. So that's what is going to happen. It's going to get fatter or skinnier as we tweak these parameters. So it's a really nice kind of feature. But now if it's very similar to what we have in our controls and what about, remember when we created that the other side, when we just sent the X section going to that in our first class. So it's kind of the same thing, but now we are controlling both in only one parameter. So now the thing here is that we could add set, Y, and make it all shrink all together. So the 3 directions, it could be getting shorter as we move the sharper if we add that. But what we are going to do is something a little bit different. So instead of doing that, we're just going to add in here now our related bounding box value here. So we're going to copy that. Oops. Just going to copy this related bounding box. So we're going to put that in here. And come on, didn't copy it. I don't want to write it. Okay. Again, here, just take relative bounding box value of my position on Y. We're going to take that and we're going to paste it in here. Come on. All right, we have it. Looks like it's working now. All right, so that is working. Now what happens here is that now you can see that I can control that amount, but based on the actual relative position of the bounding box. Now remember, the bounding box is the entire object, and now my center is right now at the very bottom of the object. So what is happening here is that I am taking that skinniest thing that I was doing with my entire object, but now because everything is related and to that position, I am getting this nice curve that is working step by step, thanks to the actual power of our power function, right? Because it's taking that value one by, well, it's a kind of smooth transition between that. If I have just a step value, it will go just all straight like that. But that's what is happening. So I'm gonna take that now, and I'm just gonna copy this into my other value here, and now we're gonna end up with a pyramid that is gonna increase or decrease just like this. Now we're sharpening the tip of that just like this. All right, a pretty cool kind of modification to our object. So that's really nice, and basically that's another option that we can create here. Now let's try to jump into another example here. Now we are starting to see functions, but we need to work with other type of variables. So I want to introduce some variables, different variables in here. So let's go and see our Wrangler attribute again. Okay, focus on this guy. New thing with same colors. Now here we are going to create now a float expression. Okay, so this is going to be a float expression, and now let's call this excuse me, not expression, a float variable. Okay, that's my mistake. Variable, a float variable. And now this is going to be called temporary, so we can call it temporary x. Okay, you can give the name that you want, doesn't really matter. And then this temporary x is going to have the position, all right, of x, just like all the time. Okay, it's going to be x with x, and let's just multiply that by 2. All right, so whatever the result of this thing is, that's what we are going to get. Now I want to get another expression, or another variable. So this is my variable, my float variable, and this variable is going to be called y. So this is what we have right now. So this is a variable, temporary x and temporary y. So temporary x is going to be equals to the position, the original position, multiplied by 2. Well, we haven't done that, so it's going to be multiplied by 2, and the same thing is going to happen with this one. All right, so don't worry about it. So at this point we have nothing's happening. Now what we need to do is just say position is going to be equals to temporary x. So in order to do that, all we have to do is take this and say that position is going to be equals to temporary x, and then we can put our semicolon, and that's what is going to happen. All right, and now you can see that this thing is working just the way we were expecting. This is just when we are dealing with variables. Now in this case we can do the same thing with our next value here. So now we could say that position in the y position is going to be equals to temporary y, the one that we just created with capital Y, and that's what we are getting, right? Kind of a weird thing. But now the weird thing here is that, you know, we are using, in both of our cases, we are using x. So that's why we are getting this result. But if I change that to y, now we are going to get this type of result. We are just adding values to what we have before. So it's actually nothing very complicated. So it's the position that we have already multiplied by 2. And that's all right? There's nothing else. There's no another kind of mystery that you need to resolve. Just take a look in here. We have this temporary value, and temporarily it's gonna its value is gonna be the original position multiplied by 2 in x, and its original position multiplied by 2 in this other direction. Now there's some sort of function that I like to use, and that's the one that we used in our previous session, and when we were talking about sine and cosine functions and all these kind of things. So now we are going to use it, but inside VEX. So here we could multiply this, instead of by 2, we could use a cosine function, right? And we could say, you know, we have it right here, and we can add in our parentheses, and we can just say, you know, add a value here. So I can say 2, and then let's say 2 by, I don't know, 2, and then by some other value, by 2. It doesn't really matter, really. So what is going to happen here is just this. Okay. Now the thing here is that nothing is moving, nothing is changing. Okay. This is happening because of the frame values that we have in our colors. So don't worry about it. But that's what is going to happen. Now I'm going to take this and I'm going to copy the same thing and I'm going to paste it underneath here. All right. Now look what happened. We get this kind of weird effect, right? Because one more time we are moving that in the y-axis. So keep attention to these things because those are the ones that are kind of getting crazy. Now because we are using that cosine function, we are getting now this kind of behavior where everything is going down. But if I want, I could use now here my sine function, okay? And we can use the sine function, and now we can turn everything up again. So you have to pay attention to what is going on in here. So these values are just random numbers that I added to this, okay, for now. But we could complicate this thing a little bit further. So I'm just going to take that value 2 and set up like this. So we could call a radiance function. We have actually a radiance function, and remember we can transform degrees into radians. Now we can use rotation values. We can, you know, it's just everything is about mathematics here inside Houdini. So if you remember just our cosine function, our sine function, it's just we can use it to make circles, you know, to create randomness, to create waves, to create these kind of things. So that's what we are going to. Well, it's not gonna. That's not what we are going to do, but something similar. So now what we need is to get our radiance function. So in this first value, let's call a radiance. Oh, radiance, and you can see how Houdini will help you here. Now inside this radiance function, you can add an attribute, right? So you could say, well, what you want to convert. So in this case, I'm just going to add number 2 in here. And what is going to happen here? Well, it's just going to increase that because the value is just so straight in there that nothing's happening, right? But that's the actual function. So we are transforming now that value into radians, which is not very interesting. So we could go like 90 and increasing the value, right? It's not going to do much right now because we don't have any type of you know, any type of value going from one direction to another. Is just straight position going moving in the x direction. So that's the thing you have to keep in mind. Now if I take this radiance, for example, and I call my function again my relative bounding box, for example, relative bounding box, we can call again relative bounding box and then declare here that we want to play with the position of which one? Well, let's say y, because we know that that position is coming from the bottom to the top, right? So that's probably help me with something in here. But as you can see right now, nothing looks to change. It looks like everything is kind of the same, because now we need another value that allows us to make get a value that allows us to you know, increase this. Let's say that we want to increase this value. Okay, so let me just go for something like 8 and see what happens. Can you see something is happening here? Let me just go and increase that value a little bit further to 80, and now you can see an effect happening, but that was too much. I mean, I was too excited. Let me just go here to something like 30, and there we go. So you start to get something, some kind of nice curvature in here. So we can create an axe, for example. If we get this value probably to, let's say, 40. All right, so kind of an axe, blade or something like that, another type of building. So that's what is happening, but I want you to see that cosine allows us to go and take that, and now the direction is going from the bottom to the y direction, and then 40 is the amount that we are using, just like in our previous exercise. So, but now the thing here is that we can use these values, and for example, just like the way we have cosine here, we could you know, get well, let's just change this value 40. Let's just make a channel. All right, so we're gonna call a channel, and this channel is gonna be a floating channel, or you know, just declare like that. We're gonna get a channel, and this channel is gonna be called bend. Okay, bend, and that's gonna be it. Yes, we are gonna end it up like this, and now we have this bend channel, and now you can see that we have this value that is going too slow, but now I can use it and get this kind of effect. All right, really cool. And now I can get my waves just like I was saying. So now you have probably a little bit more understanding of what's going on and what are we going to do. Now what happens if I take this thing just like that with radians from here, and I paste it in my sine function, which is the same but now in here. So now the thing is that it's not going to work the way I am expecting, because now the position again, it's we're using the same position, y, everything is set to y, but in here I will need now to change probably this to my x position, and now still I'm not going to get something really kind of interesting, but at least you can see something changing and something not getting on top of the other thing. Well, kind of the same thing, but at least what I mean is not just something flat in there or not interesting. So that's the thing. I want you to go and try to understand why is this happening. All right, why is that happening? Now what we can do here, we have already position here. Let me just see cosine, our radians, and now let's end the actual well, this can be a float value. Okay, so this can be a float. We can define it as a float, and then we have we can end that thing in our bend. All right, just like that. And now what we want is to add another function here. So the other function is going to be kind of the same thing, and we're going to multiply that, but it's going to be my sine function. I'm going to take that function, okay, and I'm going to copy that, and I'm just going to paste this in here. And the same, it's going to be the same function as you can see, but instead of going in the cosine, it's going to take that into the sine function. So now we are going to get that, and now the same thing is going to happen with this. We're going to take this cosine, excuse me, we're going to take the cosine, and now the cosine is going to be multiplied in here by this other function. All right, and now one more time we're going to see this thing kind of go crazy, and you're going to be like, what? This is not interesting at all, right? Now we have our end. Yep, what is going on here? Everything looks good. All right, perfect. So now the only thing I want to add in here is that after my first cosine, right, I have a cosine, and then we have our channel, and after that we have a multiplication here. But before that, what I want to do is add a minus. All right, I want to subtract the actual y position. So let's go and say subtract the y position, okay, and then we can apply our multiplication. So that's what is happening, and now you can see how it's straight again. All right, and now we're going to take a copy of this guy, and then we are going to do the same thing here underneath here, and now you can see that we are getting this. And now the thing is that if I want, now I can use this and start bending my object the way, well, not the way I want right now. Really, it's not doing exactly what I want it to do, but you can see that it's getting to some sort of point. Now the thing here is that I need to see what direction I want to take. So you can see that here our position is going in the same direction. One is going to cosine, the other one is going into cosine and sine. Then we have everything we are converting is our bounding box here into radians. So that's the value that we are getting, and everything inside here is being multiplied by the actual value that we have here called bend. All right, now the thing here is that we have this minus position y in x, and then we have the minus position y into the y. So the thing with this is that both of them are going into the same direction. But what happens if I actually take this, for example, and I add instead of subtract on this thing? So what has happened is that now we are going to get that guy standing up, and now I'm gonna be able to bend it just the way I was expecting. And yes, I know probably this is too confusing more than anything because we have a lot of stuff, but now if you take it, if you pay attention to this, just try to see it's not that complicated. We have our float, okay, this function is temporary. All we have in here is just a value, all right? And now if you haven't seen the actual sine and cosine function, I mean, that was an entire class. Just we talk about just sine and cosine functions in our previous session because I mean they are important. And I know probably you're like, what the hell happened here? Or you know, it's just something that you need to pay attention to what happens with the sine and cosine functions. They are really nice, but they deserve their own kind of class. We have a session, an entire session devoted to sine and cosine functions. But for now, you have an idea of what is happening. And if not, just let me know, and we will try to help you. For now, that's it. Thank you very much, and I will see you in our next class. Bye-bye for now. Take care. And please don't forget to subscribe to our channel. Don't forget to click on the little bell that we have underneath here. And please visit our website. We are Houdini FX. Thank you for watching. Hasta la vista, baby.